Hi, this session will be on graphing circumference, and this is from packet 108 to page 115. So I'm going to share my screen with you. And let's bring up the packet here. And let's talk a little bit about how to do this. So you're going to start with graphing circumference, and they give you a formula right here. C circumference equals 2 times pi times r being the radius. So if we remember what radius is, if I drew a perfect circle here, the radius is the line that goes right through the center, change colors here, right through the center to the edge of the circle or to the end of the circle. The radius is half of the diameter. The diameter is the distance across the entire circle. So if I was to draw a line the rest of the way here, the green plus the red is the diameter. And just the red is the radius. Just the green is the radius. So the radius can be drawn actually anywhere as long as it goes from the center of the circle to the edge of the circle. So all of these that I'm drawing are radii or radius. Radiuses. Radii is the plural for radius. So what we're trying to find out is how to graph this equation. So we're going to pick values for r, the radius, and values for c. So if I scroll up a little bit, I will see my graph goes with radius from 0 all the way to 15, and then the circumference goes from 0 all the way up to about 95. And remember, circumference is the distance around the outside of the circle. So we want to pick numbers for r, for radius, in our table that will show up on our graph. So we don't want to pick 240 because that's not on the bottom grid of our graph. So we want to pick something between 0 and 15. So let's pick something easy to start. Let's pick 1. So if I pick 1, actually let's change this over to a different color here. So if I pick 1, I'm going to plug that into the equation. I gotta scroll up for a minute to see what it was. It was 2 pi r. So let's rewrite that here. 2 times pi times r. Now we know what pi is about 3.14. Pi is also 22 divided by 7. Pi goes on forever and ever, so we usually round it to 3.14. So if we could plug in 1, color here, we plug in 1 for radius, and we solve, we'll get a number for c, circumference. So we're going to plug in 2 times 3.14 times, and our radius in this case is going to be 1. So it's basically 2 times 3.14. So you can do that mathematically. It's about 6 something, right? 3.14 times 2. 2 times 4 is 8. 2 times 1 is 2. And 2 times 3 is 6. We have 2 numbers after the decimal, so we need 2 numbers after the decimal in our answer. So C, or circumference, when radius is 1, is 6.28. There's our first point. Okay, I'm going to erase a little bit so that I've got a little bit more space again to do this different number. So what number should we pick next? Well, we could pick 2 or 3 or 4 or 5 or 6 or 7. Let's pick 10. Why am I picking 10? Because it's on our radius grid at the bottom there. So if I put 10 in, now I've got 2 times 3.14 times 10. Okay, so when we do multiplication, we can rearrange the terms. I'm thinking it's going to be easier to multiply 2 times 10 first. That gives me 20. So I'm really going to be multiplying 3.14 times 20. And if you think about 20 times 3, that's about 60 something. So let's see what we get. We're going to put the 0 here because we don't need to go 0, 0, and 0. We'll just put the 0 as our placeholder and go on to the 2. 2 times 4 is 8. 2 times 1 is 2. And 2 times 3 is 6. We have two numbers after the decimal in our factors here, or in our add-ins. What do you call those? I think it is factors. And you have to have two numbers in your answer or your product. So 62.80. So I'm just going to put 62.8. And we can drop the 0 on the end just because it's the same thing. 62.8 is the same as 62.80. Okay, let's do another one. Let's erase this one now. So far I picked some that were easier to calculate. We have to pick two more numbers. So let's pick 5, because 5 is in our bottom there. And let's plug in 2 times 3.14 times 5. And I'm going to rearrange the terms. And I'm going to multiply the 2 times the 5 first. That gives me 10. So it's really 3.14 times 10. And you can say, well, that's about 3. So I know I'm going to get something with 30, right? Close to 30. So that kind of helps you when you estimate in your head to think, okay, if I don't get that number close to 30, maybe I made a mistake. So I'll put the 0 as my placeholder. 1 times 4 is 4. 1 times 1 is 1. And 1 times 3 is 3. I have two numbers after the decimal, so I need two numbers after the decimal there. So 31.40 or 31.4. And I have to pick one final number. So I will pick, let's see, let's pick 15. Let's go with 15. Well, 15 is going to be out of our range. Let's do 12, just in case 15 makes it out of our range. So 2 times pi 3.14 times our radius of 12. I'm going to run into my 12 there. I'm going to do the 2 times the 12 first. That's 24. So it's really 3.14 times 24. And I'll multiply. So this time I have to multiply the 4 times everything. 4 times 4 is 16. Carry the 1. 4 times 1 is 4, plus 1 is 5. And then 3 times 4 is 12. Then I do the same with the 2. 2 times 4 is 8. Make sure I started underneath the 2. 2 times 1 is 2. And 2 times 3 is 6. I run out of screen space at the bottom here. I might just get it in there. 6. 8 plus 5 is 13. Carry the 1. 5. And then 6 plus 1 is 7. And then I have two numbers after the decimal, so 75.36. 75.36. And now when I graph these, obviously I'm not going to be exactly exact. So let's just erase all this and just leave our chart. So now we can plot our points. So R is the x-axis, so that's the same as if you were thinking of it in terms of x and y. This would be your x, and circumference would be your y. You could also think of R as your input and circumference as your output. Functions deal with inputs and outputs. So my first point is 1, and then I'm going to go up to about 6.28. So that's going to be just an estimate of about here, a little past the 5. Then I'm going to go to 10, and I'm going to go up to 62.8. So I'm going to go up, 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 up. There's 60, so 62.8, about there. And then 5 is going to go up to 31.4. 5, 31.4, maybe about there. We're not going to be exact, of course. And then 12 is going to go up to 75.36. That's why I didn't want to do 15, because I figured I'd be off the graph. Once you have that, you can then connect your dots. I'll do my best to connect them. There we go. That's about the best I can do. They are all connected. Okay, and I'm going to scroll down for just a second and scroll back up. So estimate the circumference of a circle that has a radius of 6.5 inches. Let's go back up. So we want to find 6.5. This is for letter B, or number 2, I mean. We're going to find 6.5 on the radius bottom here. So that's between the 6 and the 7. And we are going to actually use a straight line. We're going to go up as best we can until we hit the red line. I hit it right about there. And at that point, we're going to stretch it across and see where we end up about. So since it's an estimate, what did we land on? So we landed in the spot right here, and that's between 40 and 45. So halfway between that, about maybe a little under, I would say you would be okay estimating about 42.5. So for number 2, then we would estimate the circumference of a circle that has a radius of 6.5 as 42.5 inches. And since it's just an estimate, we won't be exact. Okay, so that's how you do that type of problem. I'm going to hit clear. And I want to show you number 4 on the bottom here. I'm going to let you do number 3, estimate the radius of a circle that has a circumference of 48 inches. Okay, so now this time you're going to have to go from the up and down numbers, 48, go across to where it hits the line, and then come down and see what the radius would be. So you're just doing it the opposite way. And number 4, estimate the slope of the graphed line. Well, now I just erased that. So let me see if I can undo that and put those numbers back. There we are. And let me just erase this now, and this, and this. So on the number 3, where it says estimate the radius with the 48 inches circumference, I think it was 48, you're going to go up to 48, and then you're going to go across to where it hits the red line and come down and see what number that radius falls on. So that's what you're doing with that. Okay, so to find the slope, you have to pick 2 points. And we have 2 points here. I'm going to pick the first 2 right there. I have an X and a Y, or an R and a C. So my X or my R is 1. So one of the points is 1, 6.28. And the other point is 10, 62.8. Brackets around it. So I need to find the change in Y, or the change in C, over the change in R. So I need to find the, let's get rid of the circle now. I need to find the distance, or the change from 6.28 to 62.8. And then I need to find the change from 1 to 10. So it's just a subtraction. So the top numbers are going to be the C's, or the Y's. The bottom numbers are going to be the X's. So I'm going to find the difference from 62.8 minus 6.28 on the top, and on the bottom, I'm going to find the difference from 10 minus 1. Now notice how I kept paired, let me circle these. I kept paired 62.8 and 10. One is under the other, because if you go back to the left here, 10 and 62.8 are paired. Okay, so they have to stay above each other, one below and one above, in the actual equation as well. Same with 6.28 and 1. And then I just do the math. So 62.8 minus 6.28. Notice how I'm lining up the decimals to subtract. Put a 0 here so that I have something above it. Can't take 8 from 0, so I borrow from the 8 and make it a 7. The 0 becomes a 10. 10 minus 8 is 2. 7 minus 2 is 5. I'm having trouble drawing that 5. put a decimal point, and then 62 minus 6, 61, 60, 59, 58, 57, 56. So 56.52 on the top. Change back to red. So 56.52. And then on the bottom, that's easy to do in your head. 10 minus 1 is 9. And now to find the slope, I have to do 56.52 divided by 9. So I'll let you work that one out. I'm just going to use my calculator here. So 56.52 divided by 9, 6.28 is what I get. So that means the slope of this line is about 6.28. That's the steepness of this red line we drew on the graph. So if I go back, look at number 4. Where'd it go? There's number 4. Estimate the slope. Okay, so we can erase all of this now and just write the slope, which we decided was 6.28 about. So let's get rid of all of this except for the 6.28. So that is the answer, 6.28. That's the approximate slope of the line that we drew. Okay, so that's how you do this problem. And then graphing temperature is going to be very similar. I'm not going to go over that one. You just have a different formula. Celsius is equal to 5/9 times the quantity of Fahrenheit minus 32. So I'm looking at this, and that's the formula you'll be using to do the exact same thing that I did on the first problem, just using a different formula. Okay, and then I wanted to do number 1 on page 110 here. Okay, so finding a common solution for the two equations by graphing. Complete the table of values. Check your answers by subtracting one equation from the other. Okay, so what we're doing, whoops, I don't use subtraction method because that's easier to make errors. I use the addition method. I show that in a different video, but this one is asking us to find the solution by graphing and not really using the algebra, but I will show you both because you may need both on the test. So the first one, we have an equation y equals 2x plus 1. The second equation, y equals negative x plus 4. So here is the first equation and they have a table. Here is the second equation and they have a table. So they want us to plug in the values they've put in the table into each of the equations. So for the first one, we have -2 as the first x. This is just like your radius and circumference, only instead of r and c now we have the real x and y, which is normally how you see it. So I'm going to plug in a -2 for x. So my equation is y equals 2 times -2, plugging that in for x, plus 1. So I just solve. So 2 times -2, always do multiplying before addition. So a positive times a negative will give me a -4 and then plus 1. So y is then equal to, what's -4 plus 1? Right, -3. So -3 is my first table value there. And now this time instead of -2, I'm going to plug in 0. They tell us to plug in 0. So multiply first. 2 times 0 is 0. 0 plus 1 is 1. It's just 1. And then instead of 0, I'm going to plug in the 2. So now I plug in +2. So 2 times 2 is 4. And then I add 1 more. So that would give me 5. Y is equal to 5. So now I've got my points for the first equation, and I can plot those. So let's go ahead and do that. So we have -2, -3. So here's -2, and then we go down 3. 1, 2, 3. Put a little dot there. 0 and 1. Go to 0 and go up to 1. 2, 5. So go to 2 and go up 5. And then we connect our dots. So the best that I can do here And I'm trying to make this as accurate as possible since we have to use it to estimate our intersecting point. See if I can get that exactly the way I want it there. Okay, let's use blue for the second equation. Actually, I want to erase this under here, and we'll make this blue. So our equation now is going to be y equals negative x plus 4. So y equals negative, and then we're going to plug in the value 0, 2, and 4. So negative 0, which makes no sense, right? Plus 4, because 0 is neither negative nor positive. So negative 0 is just 0 plus 4. So y is equal to 0 plus 4 is 4. So y is equal to 4. Okay, and this time we're going to plug in not 0, but 2, because it's the next value they tell us to plug in. So now we have negative 2 plus 4. What's negative 2 plus 4? Well, that's just positive 2. And then finally, we're going to plug in positive 4. So positive 4, and then it's the opposite of the positive, negative 4, negative x. So negative 4 plus positive 4 will give us 0. So this one is 0. So now we've got our points for the second equation, and we can plot those. 0, 4. So 0 will go up to 4, put a dot there. 2, 2, 2, go up to 2. And then 4, 0, go to 4, and you don't go up or down at all. You just stay on the 0. And then we have to connect our dots. And let's see if we can do that nice and straightly here. Notice how I'm extending it out just a little bit, because it goes on forever and ever. And then we have to find the common solution. The common solution means what point is going to be found on both the red line and on the blue line to make the equation true. So I am looking to find this point of intersection right there. So can we see what the number values are? Well, the x value is 1, the y value is 3. So 1, 3 is the intersecting point. What does that mean? Well, that means that I can plug in 1 and 3 in both equations and get a true statement. So let's prove it to ourselves that that is true. So on the first equation, I have y equals 2x plus 1. So y is now 3. 3 is equal to 2 times x. X common solution is 1 plus 1. So that equals 3 equals 2 times 1 is 2 plus 1. So 3 is definitely equal to 3. So that solution works for the first equation. It should also work for the second equation because it's a common solution or the same solution. So we have the second equation, y equals negative x plus 4. 3 is our y, and that should equal negative, and then x is 1 plus 4. So does 3 equal negative 1 plus 4? Yes, it does. So 3 equals 3. So that is also a solution to the second equation. So we have found the common solution right there, that blue intersecting point right there. And 1, 3. Now, you can graph these, and we have a nice one that worked out real nice for us. The intersecting point was right on the crisscross lines of 1 and 3. However, what happens if the intersecting point is between 2 and 3? How can you tell if it's exactly 2.5 or 2 3/4 or 2.774? You don't know, right? So there is an algebraic way to find the common solution without having to graph. And I would like to show that to you because that will be something you'll be doing in a future packet or also on the test. So I'm going to make a little white space here for a moment. I'm going to cover up our graph to prove it to you that it works this way too. Okay, so we have our first equation, y equals 2x plus 1. And then we have our second equation, which was y equals negative x plus 4. Now, I was saying that I use the addition method to do this and not the subtraction method. The answer box is telling you, I think it said use subtraction. I'm not doing that. I'm going to show you addition. But you're welcome to look at how to do subtraction as well. So I'm going to add these two equations. Now, I can't add them the way they are because my goal is to get rid of either the x or the y. And it looks really easy right now to get rid of the x's, if I'm going to add these together. So I'm going to have to add these terms, the y's, the x's, and the constants. So I'm going to multiply the bottom equation, the blue equation, by a 2. Why am I picking 2? Because I will show you that it'll make the x's cancel out. So I have to multiply every single term in the blue equation by 2. So that's going to result in a new equation of 2 times y is 2y, and hopefully I have enough room here, edge here. And then I have to multiply 2 times negative x. That equals negative 2x. And then I have to multiply the 2 times the 4, which is going to give me 8. And I just made enough room. And I'm going to leave the top equation just the way it was. I'm going to leave it as y equals 2x plus 1. And now I can officially add them together. So let's just go across, and now we can add. So we have y plus 2y. Well, there's an imaginary 1 in front of this y, so that's 3y equals, now notice what happens, 2x plus a negative 2x. That's going to be 0x, right? So that's canceling out. So we're just going to cross that whole thing off. Cancel the whole thing out. And then we have left 1 plus 8. That's 9. So now we're down to one term, which is now able to be solved. So we're going to divide by 3 because we want to get y by itself. Whatever you do to one side, you do to the other. We're going to divide by 3. The 3's are going to cross off, and I'm going to be left with y equals, and do the math, 9 divided by 3 is 3. So that is what we got over here for our intersecting point for y. We got 3. Now, how do we get the x? Well, we plug in the y value into either one of these two equations. We can pick either one. I'm going to pick the blue equation. So let's use that one just because I always try to pick the easier of the two. So now we know y is 3. So it's going to be 3 equals negative x plus 4. I just plugged the 3 value in that I got for y right there. Now I'm going to solve for x. So I'm going to subtract 4. Whatever I do to one side, I do to the other side. There we go. And now I get these cross off because 4 minus 4 is just 0. And 3 minus 4 is negative 1. So now I have negative 1 equals negative x. Well, I don't want to have this negative sign here. That's like the same as negative 1x. So I'm going to divide by negative 1 to both sides. And my negatives cross off. And I'm left with my x equaling negative 1 divided by negative 1, or 1. And if I go back to my other method, I will see that x equals 1. So that is the algebraic way to find the common solution. So you can do both ways. Try them at home so that you know how to do both. Okay, I'm going to clear this. And we are going to move on to page 113. So page 111 is going to be similar to what I just did, identical. And number 3, same thing. And then we get to page 113. So this is just showing you, these are instructions showing you how to do a graph that is not just a linear graph, not just a line, but this time it's going to be a parabola. Parabola is a U-shaped function. You'll get a parabola anytime you have an x squared in your equation. So you'll notice that the equation here is y equals x squared minus 3. So whenever you have the x squared, you're going to get one of these U-shaped graphs. And the U doesn't have to go up and down. The U could go, let me draw that for a minute. The U can go like this. The U could go like this. The U could go like this. And if you really want to get into the hard stuff, the U could go sideways like that, etc. So that's when you start getting more into calculus and stuff, and you get those sideways U's or sideways parabolas. So anyhow, what we're going to have to do is just graph the parabola. So I'm going to go to problem number 1 on page 113. So this is problem number 1. It says, for each problem, graph the equation. As a first step, complete the table of values. The first value is done for you. Then use the graph to estimate the 2 values for x as indicated. So B says, estimate the 2 values for x when y equals 6. So we'll be able to estimate after we have our graph. So we're going to use our equation here, y equals x squared minus 5. And we get all these x points to plug in to get a y value out. So the first one was done for us, so we'll go to the second one. So y equals, and x is now -3, and it's going to be squared minus 5. So do the squared part first. So -3 times itself, -3 times -3. +9, because 2 negatives make a positive. So it's 9 minus 5. So y is equal to 9 minus 5, which is then 4. So -3, 4 is one of the points. Okay, and then let's plug in the next value. So -2, and we're going to square that one. So -2 squared is 4. 4, and then minus 5 is going to be -1, correct? Okay, then we're going to plug in 0, and 0 squared is just 0. So it'll be 0 minus 5, which then gives us -5 for an answer. And then we are going to plug in 2 squared, because that's the next value for x that they're giving us. So 2 squared is going to give us 4. 4 minus 5 is going to give us -1. Notice how there's going to be 2 y values of -1 for 2 different x values. That's where the parabola is going to come in. Okay, and now we're going to put in 3 for the x value and get 3 squared, which is 9. 9 minus 5 is 4. And finally, we're going to plug in 4 squared. 4 times 4 is 16. So 16 minus 5, 11. And notice how we have 2 values of 11, the first one and the last one. We have 2 values of 4. We have 2 values of -1. That's what happens with a parabola. You'll get 2 x values for every y. Not every y, but probably. So -4, 11 is the first one. So -4, and then I have to go all the way up to 11 dot. Now I have -3 and then up 4. So -3, up 4, and I have -2, and then I go down to -1, and then I have 0, -5. That's going to be known as the bottom of the parabola. Then I have 2, -1, and then I have 3, +4. You can see the U shape forming, and then 4 all the way up to 11. And you can see that if I connect the dots, I have a parabola that looks like this. Okay, and then B says estimate the two values of x when y equals 6. Okay, so we use our graph. So we find 6 on the up and down, the y, and they say let's estimate what x is. So if we go across to where we hit the line, and then we go straight down to see what we hit, approximately hitting 3, aren't we? And let's go the other side, go all the way to where we hit the line, and we come down, approximately hitting 3, a little bit past 3 on both of them, if I had been exactly accurate. So estimate what the two values of x are. I would have to estimate it's a little bit past the 3, so I'm going to say negative 3, I don't know, 0.1, and positive 3.1, based on the graph that I've drawn. Okay, let's clear those. And if I take a look here, number 2, you get to do the same thing with parabolas. Notice how you have an x squared in your equation here, which then means you're going to have a parabola. And after that, then you get to review. So the review is going to be stuff we've already covered. So I'm going to have you do that one on your own. So I hope you have a good day, and we'll see you next time. Bye.